Assalamualaikum warahmatullahi wabarakatuh. I'm Syazani bin Syamizey from BENR to BENR S2, Fakulti Kejuruteraan Elektronik dan Kejuruteraan Komputer FKEKK. Today I want to present to you BENR 2211 Computer Engineering Laboratory 2, Arithmetic, Logical and Branch Instruction. So, by using the Kill Using software, we must complete the exercise given, exercise 1, exercise 2 and exercise 3. Exercise 1 is for arithmetic, exercise 2 is for logical, and exercise 3 for branch instructions. So we must translate the instruction given by the exercise to get the assembly language types and run it into Kill Your Vision software to get the answer in the register. So as you can see in the screen, this is my first exercise, exercise 1. Alright, so as you can see here, for exercise 1, this code, error my code read-only entry export system init export main system init main is just initializing code for the UVision to start running the code. Okay, let's go to the part of the code. So this is the code that given. This is the code that I get from the instruction given by the exercise 1. So this is load R0, R1, R2 with the value given 874, 5578 and 5. Okay, firstly, I use the move instruction to store the value immediate store in the register R0. I choose R0 to store 874, then I choose R1, move R1 for immediate data 5578. Because we need to store the data 5578 in R1. Next, R2, we must store 5. Then, I store 5 in R2. So, the code is move R2 #5. So, what is R4 and R5 here? So, R4 and R5 here is I just create it for temporary to store the data 6 and 100 for later use. Next, you will see why I use R4 and R5 in this coding. Okay, but first I want to tell you that R4, I move the data 6 and R5, I move the data 100. Alright. So next, the part of code. Mul. Mul is the multiply in UVision software. So we use mul. So R2. So R2 divide by R2 and store in R2. So I square R2. Square R2 means R2 times by R2. So we get the answer R2. Then the next line is add R1, R2 and store in R3. So what we must do is add. So we use the add instructions. Then we must store in R3. So R3, then R1 plus R2. R1, R2. The next instruction, we must subtract R0 from R3 and store in R3. Okay. So, for the subtraction instruction, we use sub. So, store in R3, we store R3. Then R3, we must subtract R0 from R3. So, R3 first, then R0. Next, the multiply instruction. So, we must multiply R0 by 6. So, this is why I use R4 to store the 6 in R4 because I want to easily to directly multiply here. So I'll store in R0. So R0 times R4. R4 just now is 6. Then I multiply R4 by R0. So we will get the answer when store in R0. Next is subtract 2477 from R1. Alright, so we store in the R1. So R1 2477. R1 minus we will subtract 2477 from R1. So from R1 and we'll subtract 2477. Alright, this is the code. So next, divide R1 by R2 and store in R1. Alright, so For the storing in R1, so I use the instruction udiv here because the Kale Vision software support the division command. Then we will store in R1. Then next divide R1 by R2. Alright. So the next instruction given is square R1. So as usual, square R1 is equal to R1 times R1. Then I will store in R1. I use the instruction mul. Then R1 times R1, we will get square R1. For the next line, subtraction. Subtract R1 from R3 and store in R3. I store in R3, then I will subtract R1 from R3, and I will subtract R1. So this is code look like. Lastly, after we get the answer, we will divide R3 by 100. So when we divide R3 by 100, because the answer that we get here will be negative. So when we get a negative answer, we cannot use U division because udiv is for unsigned numbers. So the alternative that I use here is sdiv, is for signed numbers. So I use sdiv here to divide R3 by 100. Okay, just now I move the data 100 into R5 because I want to use it here. So R3, we will divide R3 by 100. So R3 divided by R5 means R5 is 100. So we will get the answer and we will store in the R3. Then align and end. We must put align and end because that is the way to stop the entire program. So next I will debug it, start and stop debug session. So the function of stop and start debug session is for we can see whether our code is running right or not. Alright, so no. The first thing I should after I write all this code here, so I will project and then I will build target. So I will build target. I will see down here whether it has error or not. So if it's not error, so we can run this code. So if it have an error, so we must check the error, run the troubleshoot and find where the error is, whether it's a logical error or something like indent or wrong spelling can cause the error. So after I check after I build target, so no error, then I will go to debug and I will start the debug session. Alright, for the debug session. Okay, as you can see here, okay, this is what we call the computer must doing some routine to understand our code written. So after to looking for our code, right, we click step into. Okay, this is our code that I write here before. So next we will see whether our code is right or wrong. We will see the flow from this top and until this execution. Right, I will click step into, move R0874. Alright, so as you can see in the R0 now is 0x00036A. Okay, why here is 36A and here is 874? It is meaning is the computer didn't understand the decimal value. So after you read the decimal value in the code, you will translate to the hexadecimal value, that is 36A. Okay, next we will move R1 5578. 157X represent 15CA, 15CA, right? So then that is for R1. So step into. So in the register R2, you can see the value 5 here, right? Next, for the R4, we can see the move R4 step 6 that I save data from 6 to the register 4. Next, we will see R5 as 100. So 100 in hexadecimal is 64. Then we go to the multiply R2, store R2. R2 square R2 means R2 times R2. Okay, as you can see here, R2. The new R2 here is 19. Right, 19 in hexadecimal. Next, we will subtract R0 from add R1, R2 and store in R3. So R1 and R2 we will add together and store in R3. So R3 will get a new value 1583. Then we subtract R0 from R3 and store in R3 also. So as you can see here, R3 got a new value because R0 subtract R0 from R3. So we take this R0 from R3 and store in R3. So we store in R3, subtract R0 from R3 means R0 from R3 just now. The value of R3 just now, we will subtract R0, 874, and we get the new value R3. Then we will multiply R0 by 6, R0 there. So hence R0 will get the new value 147C. U division. Next, sub R1, R1 to 477. So as the value, the new value for R1, the value for R1 is 5578. Then we subtract 2477 and then we store in R1. Hence R1 we get a new value 000 C1D. Okay. Next we will use diff. So divide R1 by R2 and we store in R1. So R1 will get a new value 007C because we divide R1 by R2. We divide R1 by R2 because the new value for R2 is this right here. Alright. Next, after we divide R1 by R2 and store in R1, we will square R1. So R1 we will get a new value. After we square R1, we get 3C10. Okay, next for the subtraction, we subtract R1 from R3 and store in R3. So R3, subtract R1 from R3. Subtract R1. Okay, R3 we minus by R1 and we store in R3. So R3 we will get a new value FFFFD669. FFFFD669 means it is a negative number, a sign number. So that is why I use SDiff here, because I want to get the answer because using the SDiff. So R3, R3, R5. Then I will divide R3 by 100. So 100 right here is R5. I'll save the 100 value earlier in R5. Then I will divide with R5. So R3 here will we get the new value. Okay, so we wait a while. Okay, as you can see here, this is the final value that I get from register. So the final value for R0 is 0x0000147C. R1 is 0x00003C10. R2 is 0x0000019, and the value for R3, just now we use SDiff R3, divide R3 by 100, but using a sign number division SDiff, this set of instructions. So then we divide R3 by R5, so we will get R3 0x FFFFFFF 96. So this is to conclude all the answers, the current, the latest registers from all for what is set of instruction that we are doing here. From the stop instruction and until the bottom instructions. So this is the final answer we get from step into, and it is performed line by line to get the answer. So this is R0, R1, R2 and 3. Okay, so next we will move to the exercise 2. So exercise 2 is for for logical instructions. So the logical instructions that give in the exercise 2 is this. The first instruction is load R0, R1, R2 with 0x1234, 0xABBA, and 0x55A5A. So as usual, we will push this value into the register. So in R0, we will store 0x1234, R1, 0xABBA. So R2, we move 0x5A5A first, because the next value of 5, we will use the instruction move top R2. So we will push the value 5 in the top. So lastly, we will get this value 0x555A in the register R2. So next, the next instruction is as for set the bits 4, 5, 12 and 13 of R0. So what is meant by set? Set is we will move the 4th, 5th, 12th and 13th bit we will set by 1. So that is what is meant by set. So here, for the 4th bit I will set 1. So the 5th bit I will set 2 and 1. So the next bit I will set 0 until the 12th bit I will set 1, and 13 bits I will set by 1. So when I OR this binary number with any number, I will get the 4th, 5th, 12th, 13th bit will be equal by 1, and the rest of the bits will be equal by 0, because set means changing bit into 1 and the clear means changing bit into 0. So next we will move to the LSR R2 shift 2. So the LSR instruction is mean by divide R2 by 4. Divide R2 by 4. So we left shift R2. Okay, next instruction is LSR R2 immediate data 2. What is meant by LSR is logical shift by n bits. So we want to divide R2 by 4. So 2 power of 2 equal to 4. So we logical shift by n bits. Logical shift. So we shift by 2 bits and sign division by 2 power of n. 2 power of n equal to 4. Then next we will MVN R2 and invert the result. What is the MVN means? MVN means the short for move negative, and it will move one's complement of the operand into the register. So we invert 0 to 1 and 1 to 0. Next we will move R4. The next instruction is clear bits 2, 4, 6 and 13 in R1. So for the second, 4, 6 and 13 bit, we must put 0. We must put 0 in this register, because clear bits mean everything we will clear into 0 and the rest will become 1. The rest will become 1. So we look for backs 2, 4, 6 and 13 in R1. So we end with R1. If we end with any number, so the second, 4th and 6th and 13 bits will become 0 and the rest will become 1 in R1. So next instruction is end R1 R12. So we start in R1 first, end means R1 and R2, and with R1 and R2. Next instruction is ROR. The next instruction is rotate R0 2 positions to the right. and OR it with R2. Okay, so what is mean by rotate R0 2 position to the right? So we use ROR, logical. What is mean by ROR is logical rotate by n bits. So if it can rotate to 32-bit rotate, so this instruction here asks we to rotate R0 for 2 position to the right. Then we use ROR, R0 immediate data 2. Then we OR it with R2 and we store in R0. Okay, next align and end. Just a basic routine to complete this all. So as usual, I will click project and will target, see whether it's an error or not. Okay, perfect. It have no error. Then I will go debugging. I will start the debugging session. Okay, so we click step into until we see the first code. Okay, first code here we will move data 0x1234 into R0. Alright, so R0 here we will see 0x001234. Okay, the next instruction is move R1 0xABBA. As usual, you can see the data here we will transfer into R1 ABBA. Then we move R2 equal to 0x5A5A. The instruction here 0x55A5A, but first we will move 5A5A first in the register. Then we will move top 5 in front of this to become the 0x55A5A. Right, next. Okay, as you can see here, R2 is equal to 55A5A. Okay, next we will move R4. We will set the bits of 4, 5, and 12, 13 of R0. Right, so you can see here R4 equal to 001818. Then we will divide R2 by R4. So R0 here we will get a new value 0800183C. Okay, next we will LSR R2 #2 means we will logical shift for n bits 2. We must divide by 4, so 2 over of 2 equal to 4. So we will shift 2. Then we will invert the results. Okay, you can see R2 we will get 15696. 15696, but it didn't inverted yet. Then I will invert, and after invert we will get FFFEA 969. Then next instruction is we will clear bits 2, 4, 6, and 13 in R1. So clear means for the second 4, 6, and 13 bit we will become 0, and we will end with any number, it will become 0, and the rest of the bits will become 1. So we will see here R4 will successfully put the bit here. Then we will end, we will clear bit and R1 with R4 we clear bit to 4 in R1. So we will store in R1. R1 will get a new value 0800AB90. Okay, the next instruction is we will end R1 and R2 and store in R1. So R1 will get a new value from this new R1. We will end with R2. So R1 will become 0x00A900. So next is we will rotate R0 2 position to the right and OR it with R2. So we will rotate R0 #2 means immediate data 2. Then we will OR it with R2 and store in R0. Okay. For the last instruction, we will this revision will take time to get the final answer. So we wait a bit. Okay, finally we get the answer. So R0 will be FFFEAFEF, R1 000 A900, R2 FFFEA969, and R4 is 000 EFD5. So this is the latest register after we proceed with all this line by line and the logical code. Okay, next we will go to the exercise 3. So what exercise 3 given us is a branch instructions in ARM. So we must convert this following C code to the assembly language, and we will write the program in CalUvision software. Okay, what we have here is result equals 1, the while value less than 10, and then if true, if value equal to 7, you will check value with plus and continue with going back to the while, and then else result equal to the value for result, you will equal result plus 3. Then for the last instruction is value plus means that assigned value will be increment by 1. So this is the loop of branching that we must convert in the assembly language for CalUvision software to understand. Okay, firstly what I'll do is I will create a flowchart because I want to see the exact flow without any error for me to see it in the clearer view what it will gonna be. Okay, this is my flowchart for exercise 3. So we will begin with start. I will assign the value for R0 is 1, and I will R0 means result, and R1 means value. I will assign the value 5. So I will start the program. So for the first condition, it will check if the value R1 here is less than or greater than 10. So if not true means that R1 is more than 10 or equal to 10, it will straight go through to the ends. Mean it will not continue to execute all of this instruction. So if R1 less than 10, if is true, means that in this I assign R1 value equals to 5. 5 less than 10 mean is true. So if it's true, it will check whether the R1 is equal to 7 or not. So if true, if R1 is equal to 7, then we will go next to this instruction. So R1 will be increment by 1 if R1 is equal to 7. If R1 is not equal to 7, by mean of that is false. So the value of R0 is not R1, so the value of R0 is 1. So it will be increment by 3. So 1 will be plus by 3 and store in R0, it will be 4. And then again, after executing this condition, you continue to execute this condition R1. So R1, our value of R1 is 5 here. I will add it by 1. Then it will be the new R1 value is 6. So then it will continue to execute. It will continue to go to the while loop and check again whether the new value of R1 is less than 10 or not. If less than 10, it will go to the false and will end the loop. If it's true, it will go check again whether the new value R1 is equal to 7 or not. So it will continue running loop until it will not fulfill the condition R1. Okay, so we go to the code that I write. Okay, this is my code that I write. So as usual, we will use this as our pendahuluan, as our start for assembly language to do the routine for MDC kill. So for right here, I assign R0 as 1 to the result of 0. I assign 7 into the R1, assign 5 to value. I will assign 5 actually. I assign 5 to value R1. So this is a loop. So mean branching, I will use loop in this code. So firstly, what I have to do is I will compare the R1 with 10. I will compare R1 to 10. If R1 is more than 10, kalau R1 ni lagi besar daripada 10, it will done. Branch greater or equal done means it will not continue. It will straight go to the end because the value itself, the R1 value is more than 10 means it will not fulfill the other condition and will not running. So next, if R1 is less than 10 means this fulfill the condition, it will go to the next instruction, compare R1 equal to 7 or not. So I will compare R1. So the R1 value is here is 5. 5 is not equal to 7, mean it will not execute this instruction add equal to R1 plus 1 because R1 is not equal to 7. R1 here is 5. So we will go to the straight to the loop if equal. So add if not equal, add NE. We will add the value R0. R0 here is 1. We will increment by 3, means the R0 will be 4, and after the value of R0 increment, next we will add by R1, the new value of R1. So R1 is 5. We will increment by 1 is equal to 6. So after it execute all of this instruction, you will go back to the compare one. So you will check the new value R1 whether it's less than 10 or more than 10. So it will continue running until it will not satisfy this condition and will go to the end. Okay, next we will go to project and build targets to see whether it has an error or not. Okay, perfect. It has no error. Then I will go to the bug session. I will start to debugging. Okay, as usual, I will step into to see our code. Okay, load R0 equal to 1. So I will assign 1 to the result R0. R1, I assign 5. So we can see it will compare the value of R1, 5. After I load R0 equal to 1, R1 equal to 5, it will compare R1 whether it's less than 10 or more than 10. Mean that R1 here is 5, it less than 10. Okay, it will continue to execute these things. CMP, it will compare R1 to 7 next, because we want to check whether R1 is equal to 7 or not. If R1 equal to 7, it will execute this instruction, but it's not because our R1 is 5. Mean it will not execute the instruction. It will go jump straight through to the add not equal to R0. We will increment by 3. So means that 1 plus 3 is 4. Okay, so we go step into, then it will not increment R1 by 1. It will not run this instruction because our R1 is 5, is not equal to 7. It will add NE, so it will add 3. So we can see step into our new R0 is 4 because we increment by 3. So next instruction we will add R1. Our R1 here is 5, so we will plus by 1. 5 plus 1 equal to 6. So you can see here our R1 is 6. Next you will check again whether is compare R1 is equal. We will check again our R1 is 6, less than 10 or more than 10. It will continue running. Okay, next let's say, okay, firstly I will start the debugging session first. Okay, let's say I change the R1 is equal to 7. Change the R1 equal to 7, and then I will project. I will build target. Okay, then I will start debugging because it have no error. Okay, I will step into. Okay, I put value 1 into R0, 7 into R1. Okay, as you can see here, 1 and 7. Okay, we will compare R1 less than 10 or not. Yes, true, R1 is less than 10 because our R1 here is 7. Okay, then we will check compare R1 is equal to 7 or not. Okay, right here is our R1 is 7, means it's true. Means that it will continue to execute this instruction. Because just now our R1 is 5, it will not continue execute because it's 5 is not equal to 7. But this is 7, means it is equal to 7. It will continue to execute R1 equal to R1 plus 1, means 7 will be plus by 1. Our new R1 is equal to 8. Okay, our new R1 will be equal to 8. BEQ loops. So if equal, then it will continue. What is meant by continue? It will go back to the CMP. It will check again whether is 10, whether is 8 less than or more than 10. Right, step into, yeah, right. It will check because it will continue. Means if it equal to 7, it will go back to the loop where is R1. You will check again R1 is equal to 10 or not. Then 8 is less than 10. Yeah, right. Okay, done. Compare. We will compare 8 is equal to 7 or not. Not 8 is not equal to 7. Next, we will skip this instruction because 8 is not equal to 7. So means 8 is still by 8. We go. So R0, our new R0, 1, we will increment by 3. So 1 is equal by 4. Then we can see here 4. So add R1, R1, 1. So our R1 just now is 8. We will plus by 1. It will equal to 9. Okay, 9. Okay, 9. So next, we will step into again. We will compare R1 is 9 less than 0. Okay, so as usual, you will go. Then we will check if the value R1 is 10. Okay, so right now is R1 is 10. Okay, 10. We will go to the compare R1 is equal to 10. Means it's not less than 10. It will straight go through to done. It will not continue to calculate because our value R1 is 10. Okay, that's that is our answer, my answer for exercise 3. So thank you so much for your time, and I hope this video can help you guys. So thank you very much.